Hi, welcome to my channel. In this video, we will be making Arduino Pro Mini flexible PCB on EasyEDA software by JLC PCB, and then we will order that PCB on PcbWay. So let's get started. First of all, you will download EasyEDA software and make account on that and log in on EasyEDA. I have given a link to download EasyEDA in the description below. Just verify and sign in. So go to File, New Project, create a project. I will name it Flexible Arduino Pro Mini. Save it. Now first of all, go to Google, search for Arduino Pro Mini, and at the very top site you will get to the arduino.cc. Here you can get the original document of Arduino Pro Mini. Open the schematics in PDF. So we will be making this schematics on EasyEDA. First of all, we will make the part list. It is called LCSC part number. LCSC is the site of JLC PCB. So we will just write down all the parts we have in this PDF. We are simply writing down the prefixes of all the parts given in this schematics. Now I will sort the same category of components. So for example, I have placed capacitors at the top, then resistors, so that while searching on LCSC site it would be easy. Now we will go to the LCSC site. LCSC is the store of JLC PCB, where they have all the components. Here you have list of components on the left side: capacitors, connectors, oscillators, etc. We will go to the capacitors first, and we will search for SMD capacitors, multi-layer SMD capacitors. So the first capacitor we will be needing is the C19, which is 10 microfarad. We will search for 10 microfarad and a package size of 0402 and apply the search, and we will click the availability so that the highest available gets on the top. We will just copy the LCSC part number and paste it in front of the component. Next capacitor is also 10 microfarad, so we will just copy the previous and paste it. The next is 0.1 microfarad. So we will search for 0.1 microfarad. We will reset the package, and 0402 we select the only one they have, so we have to research it, research for it. What we will reset the capacitance. The 0.1 microfarad is also 100 nanofarad. So we will search for 100 nanofarad capacitor, and then 0402, and then now you can see there are 345 capacitors in the list. So we will go for the first one because it's the most abundant capacitor in the LCSC site. We will just copy paste the LCSC part number into our notepad. The next capacitor is also 0.1 microfarad, so we'll copy paste that. Okay, so the next capacitor is 0.1 microfarad again, so we will copy and paste it. Now C3, and C3 is 0.1 microfarad again. Okay, now we will search for the resistors. Go for products, find resistors in the left directory, click on resistors. You will see all the types of resistors. We want surface mount resistors. Go for surface mount resistors, and the value we need is 10k. So we will search for 10k here, select it, and package is 0402, and there are 200 elements there, and then we apply the filters and check the availability. And the very first one, we will copy the LCSC part number and paste it on notepad. Now we will go for the second resistor, which is also 10k, R2. So we will copy paste it. The next resistors in the list are R1 and R3. They are optional pull-ups resistors for I2C line. They can also be 10k because they are just pulling up the I2C lines. Next resistor is R6, which is 330 ohm. So we will search for 330 ohm, and package is 0402 again, and we will apply it. 109 elements are available, and we will copy paste the very first LCSC part number. Now remaining are two main ICs. One is the voltage regulator, MIC 5205. So we will search for MIC 5205. It's a 5-volt voltage regulator. We will check the availability, and the second one we will choose because here you can see they have also choose 5205 of 5 volts output. So we will choose 5-volt output. We will copy the LCSC part number and paste it in our notepad. So similarly we will search for U1, which is at mega 328E. Okay, we will check the availability, and we do not have at mega 328P here. Let me choose the keyword 328 without space, and here we found the 328P in the second number. This one. We will copy paste its LCSC part number. Now we will search for LEDs. Go to home. In the left panel, search optoelectronics, and optoelectronics you search light emitting diodes, LEDs. Here it is. In LED we LED 1 is a power LED, and we won't be using power LED in our project, and also we won't be using the reset button in our project, so just remove them. Now we will search for the crystal oscillator. Click on crystal oscillators and resonators, go for crystals, and we have 16 megahertz of crystal. So in the filter, search in the frequency bar, search for 16 megahertz, click it and apply. Before applying, choose all the SMD parts, because we only need SMD parts. Control and just right click on parts, left click on the parts, and you will select all the SMD parts. Apply the filters, check the availability, and we will use the very first one, having 16 MHz crystal resonator and 9 picofarad of capacitance. Okay, we have gone for it, and now D3, which is green LED, we will be using this LED. So products, optoelectronics, and LEDs. Choose the packet 0402 and LED color is green, so all the green LEDs. Check the availability, and the most abundant we will use this LED, but before choosing that, it's better to go through the LED datasheet. Okay, the first one. So we will just click the datasheet and the PDF will open. We have to check the forward voltage of this LED. There it is in the first column, in the first row, sorry, VF is 2.4 volts. So it's pretty good for our use, because we are using 5 volts and we also have a 330 ohm resistor. So this is the right choice for us. Now we will go through the headers, JP1, JP7, JP6. Okay, go to home and connectors. Here it is. Search for pin headers or female headers. I think pin headers. Here it is. Okay, the pitch we are using is 2.54 plugin, because all of the headers commonly are 2.54 mm pitch. The rows we have is number 1, and the number of pins we are using in JP1 is 1 2 3 4 5 6. Apply the search, check the availability, and go for straight 2.54 mm. Copy its LCSC part and paste it in the notepad. Similarly, go for JP7 and JP6. We have 12 points for them. Straight headers. And now the JP2 and JP3. Now our component list is completed. We will start placing those components in our schematics. So let me show you how to place it. We click the library option. First copy the LCSC part number, click the library option in the left panel and copy paste the LCSC part number, paste it here, click it, and the very first option is there, and click it and place this resistor in our schematics. So this resistor is what we exactly want. Okay, now start from the upper left corner of the schematics. First we will be making the voltage regulator, so just delete it. And the first reference capacitors, choose the C19 capacitors, copy its LCSC part number, paste in library, search for it, and then place it in the schematics. Press R to rotate your component. while selecting it. The next component is the MIC5205. Go to library, and 5205 is U2. Copy its LCSC part number, paste it, search for it, and place it. We will repeat this procedure for all the components there. We will not be using LED. Okay, now our components are placed. Click save. Now we have all our components, as well as set the Okay, now we will start routing. In the wiring tool, select the ground and place it in the to the negative side of the capacitor, and the other ground to between the MI205. Just grab the ground and place it somewhere down to look like clean. Connect the ground pin with the ground, and the in pin you can select the wire by pressing W or selecting from wiring tool. Connect the in with the capacitor, select the net, connect the net at capacitor positive and NY and label the net as raw. You will be providing our power source here. Connect the enable pin with in input pin, so it's always enabled. And similarly draw other connections. Grab the net of VCC and connect it with the output of our power voltage regulator, which would be exactly 5 volts. So VCC net symbolizes 5 volts. Wherever we put VCC in our circuit, it would be a 5 volt. Now grab the rectangular window and place it in the voltage source and name it as power regulator to make our schematics look clean. Now we will make connections of our Atmaga 328P. Find a reset pin in our footprint, and it's there. It's the 28th pin, sorry, 29th pin in the reset. Now our side of at Mega 328p is also completed. Grab a big box and envelop it, copy paste the text and annotate it as at Mega 328p. Now only headers are remaining. Okay, first click all the headers and turn off the display name. Now they're nice. Now we will place nets on all the headers and we will name the nets according to the pins. Now our headers are also completed. We will grab copy paste our box and resize it to fit the headers, and in this way our schematics is nearly completed. It's nearly completed. Now we will go to the design managers and check for all nets. It shows the warnings for 3 nets, A4, A5 and U1 pin 4. Yeah, it's getting warnings because they have not a complete net. The net is not complete. We will U4 is open, and we will place a cross on U4 pin 4, U1 pin 4, sorry. And now we will look for A4 and A5. It looks like they have only one net. At least there must be 2 nets of a single node. So A4 and A5 are these 2 pins, pin number 27 and 28, ADC4 and ADC5. So we will place, first look at the schematics. Yes, we will place them. We will place the nets at ADC4 and ADC5 and name them as A4 and A5. We will remove the nets to make them more clear. So we'll copy and paste the A5 net, and we will press W to get a wire and attach that net with the pin 28. Similar with A4, bring backwards, and we will do the same with the reset. Now it's much clean. Let's save the project. Let's place on the right, left. Okay, now we will rerun the nets, and now you can see there are no warnings. Similarly, we check all the components and there are no warnings. So our schematics has no DRC errors or no net errors. Schematics is completed now. Now we will look for our initial design, which we need to design with a flexible Arduino Pro Mini, and we see that there are 6 pins here, not the 12, and 6 here. So we have divided this 12 pin header into the 6 and 6, and A4, A5, A6 has a 4 pin headers instead of 2 and 2, and the pogo pins, programming pins are the same. So we will divide this 12 pin header into small 6 ones. Go to the common library. We can also place components from here, some basic components. Select in the connectors, go for pin 6. This is a female connector, and we want a male connector. So in the left side we have male connectors, M for male. Choose 6, click it, and this is our header. So we will place it somewhere here and delete our H2 and H3. We will connect with the nets, connect the J1 with the nets, copy the J1, Control C, and we will paste it in the lower 6 pins, and we do the same with the other one. We will do the same with A4, A5, A6, 7 pin, a 4 pin header. So a 4 pin male header, we will select it and place in schematics. Delete H5 and H4 and cut them and paste them in the bottom side so that we have a good sequence. A4, A5, H6, H7. Now it seems that our schematics is completed. Save it, Control S, connection successful, and it is saved to the online repository. You can also access this schematics on the online repository. Just go to the online EasyEDA and log in there. So check the pin roughly on the already made Arduino Pro Mini available in market. D10 Mose Mazo, but they have D10 11, pin 11 and pin 12. Okay, A0, A1, A3, A2, A3 in the upper header, VCC, RST, GND. Okay, we are good, but we have to change the name of Maizo, Mose and SCK to pin 11, 12 and 13. So let us do that. Change Mose to D11 here, the third pin, the second pin, sorry, and also at that mega site change Mose to D11 and change MISO to D12 here, the third pin. Untitled mega side, similar with serial clock, which is D13. Okay, let's check that. It's okay, it seems good. We have a nice sequence, 98765 and 98765 23G and D, and reset RX TX0. All good. And a toggle pin ground VCC RX TX and DTR. Okay, so we are good to go. So our schematics is now finalized, it's completed. Let's place text of Arduino Pro Mini, flexible Arduino Pro Mini. Let's increase the font so it looks much better now. Save your project, successfully saved. So now our schematic is completed, and now the final step. The next step, is to convert the schematics into PCB. So we will go to the designs and convert to PCB. The EasyEDA will automatically convert it to the PCB, and we will set the length and width of our PCB. Let's check in the document. The width is 35.54, width is 35.54 mm, and height of PCB is 18 mm. Apply, and we have 35.454 by 18 mm boundary of our PCB. So now we will start placing our components inside the boundary, inside our layout. This is a 7, a 6, so we'll place it here as in the already existing PCB. Okay, now the digital pins. Just click the digital pins in the schematics and it will automatically highlight in the PCB. Oh, it didn't. Wait a minute, go to the schematics, click it, J3, and yes, it highlighted. Similarly, A2, A3, A2, A3, this one, click it, it will highlight. Sorry, we have already highlighted that. A1, A0, bring it here, and now 9871. It is D10, D11, just to confirm. The end is raw. Okay, it's good. Now the J1, select the J1, it will automatically select it. Now this should be D4. No, it should be D9, okay, because D9 8765. And the last one. G3 TX, okay, rotate it. TX is the last. Now select both and align them. We will half place the headers on our boundary because we need to create a patch of flexible PCB, and we will not be soldering these headers. So we are using these headers. Okay, we will now calculate the distance between the two headers. 2.54 multiplied by 2 is 5.08. Because the pitch is 2.54, so we will skip the center header. Now let's place it here. And by the way, these measurements come from PCB tool. Adjust it a little bit. Now it's perfectly aligned with the border of PCB. Press the calculator. Okay. Similar, we will do the similar thing with the upper header. Just at the right side. Okay, now with the upper header, we'll copy the measurement and we select the measurement, make it 5.08, and we will bring the other header to fit in our measurement. Okay, it's perfectly aligned. We'll select the both and align them and bring them downwards, little bit left, up until the center point of the header is on the boundary. It's perfectly aligned now, and it is also aligned with the lower header. If we see the boxes, the grid, we will select this header now, take it to the boundary of our PCB. We will align it with the boundary. Here it goes. The last header we will place it at the left side, on the left side. Okay, now just reduce the size of annotation to 0.1 to 0.6 mm. Now we will select the components which are directly connected to the ATmega 8328P, and these will be highlighted in the schematics. We will separate them and we will arrange them in the PCB near ATmega 328P. During PCB placement, the important point is to place the components as near as they can be and in such a way that their routing is easy. The pins that are interconnected should be very near. As you can see, I have placed the C18 very near to X1 because its pins are directly connected to the X1 if you see the schematics. Also with the C7, because C7 and C8 are directly connected to X1. So when we run the auto router, it will auto routes it successfully. Select these resistors and align them. Now our placement is nearly completed. Just make sure that everything looks beautiful and also it is placed efficiently. So the gap between the two headers is the bending area. Now we will place the mask. We have selected that in the PCB tool, the dotted square. Okay, now we will place the boundary of the PCB. it goes. Complete it or select the PCB and layer to board outline. Change the layer to board outline and then auto router and run the auto router. I have given the link in the description to download the auto router. You can also use the local available auto router. So wait, and it is completed. No, it is not completed. Okay, we will delete these two resistors. You can see that the routing is not completed, so we will delete those resistors because they are not really useful for us. They can be placed outside in the circuit if anyone wants. Save your project and design update PCB. Like apply changes and yes to settings. Now auto routed again. Okay, click unroute all. Now click auto route and run. And now it is completed. Failed 0. It will build the copper area. Now it has left the area, so what we need is to allow it to keep island. Yes. We'll try to select and copy paste it to make the lower layer. Just copy it, paste. Here, select it again and change its layer to bottom layer. Now readjust it and right click, select copper area and rebuild all. Design menu will check net and we see that ground net is not completed, so we will auto route it and skip nets. And it's again failed. So now what we will do is just refresh and check, and yes, the ground net is not completed. It has left the ground net because we have skipped the ground net. We thought that if we place the ground layer on the upper and lower, then there would be no need to trace the ground net, but it seems that there is a trace. There is a need to make a track of ground. We try to place via and make a ground to just connect these two pins. It doesn't work, just remove it. Make some distance between these two capacitors, these three capacitors, C8, C4 and R1. Okay, just correct the trace so that it is inside the PCB. Okay, so let us unroute all and increase the space between R1, C4 and C8. Now we will try to auto route it, including the ground net. And we also reduce the clearance and run. I hope it will complete in this attempt. And yes, it is completed. It will build the copper area at upper, top side and bottom side of PCB. Now we will again check the DRCs and it's clear there is no warning at last. Now we will check the trace of individual pin. It is correct. It is also correct. Here it is not correct, so we will just lower it. Select the bottom layer and we will lower it to make it inside the PCB. It's at the edge of PCB, which can be hazardous. Similar with this one. Oh, we'll just delete this one. Just delete it. Let me remake. Select the wire from PCB tools and make a trace manually. Okay. Now similarly check all traces. Just right click on anywhere, or just keep on looking at individual pins. Okay, this is also not correct. Okay, now everything is set. Just right click anywhere and build the copper area. Build all. Now check the nets. It's alright. Check the DRC. It's also fine. Okay, now we are good to go. Just delete the outer boundary. Save your project, Control S or file and save. Let's view our PCB in 3D. These are all the components which are present in GLC PCB, so that's why their 3D model is also available. We have picked these components there and it looks good. The naming of the prefixes of components looks quite big. Let's view it in 2D. So here is our PCB and this is the final product. Okay, now we will annotate the pin numbers, digital and analog pin numbers and programming pins. Try to use the width and height such a way they are clearly visible. We have to make our annotation smaller. Let's go for 20 pixel height, and now it's perfect. problem that the header and the header outline is also there, which should not be at the top cell layer. So we have just clicked the header and make it slave to the bottom layer, and we have rotated it at 180 degree. Make it prefixed with the top layer, top cell layer, and adjust it. Similarly, annotate the name of pins for this header. A2, A3, and 6 pins. If you see at the pins of headers, it's also displaying the nets, raw, G and D reset. If you zoom in towards the headers, realign them, select all and press down key, and they will drag downwards. Now similarly, select this header and lay it to the bottom layer and rotate it at 180 degree by pressing R on the keyboard. Make its annotation to be the top cell layer, because that is also converted to the bottom cell layer as once you make it at the bottom layer. Similar thing goes for this header, and we will repeat these steps for all the remaining headers. Let's do in the 3D. Our size of annotation is quite good, is readable. So now we will also short down our height of annotation of the components because they look quite big. Now we look at a 3D view of PCB. It's looking quite good. Now we will annotate this remaining header. Now our PCB looks quite good. The last header. Now it's completed. Let's view in 3D. The final PCB looks like this. Oh, it's not final, sorry. We will measure the length and width of our PCB to check if it meets our design requirements. Just select both of these, reduce the height to 50 and the unit to millimeter. It's 35.560, nearly equal to 35.550, or we can adjust it to the 35.540. Similarly, we will measure the height. We will change its unit and its height to 50 and its unit to millimeter. You see it is 18 millimeter nearly. We can make it to the full 18 millimeter. We have just increased the width of our scale. So reduce it to the 50. Now we will place the line where we will bend this PCB in future, because this is a flexible PCB. So we need to make a marker for that where it can be bent. So we are placing these lines, dotted lines, and we select them and align them, distribute equally, and give it downwards. Okay, so the traces in these in this line, in the way of this line, needs to be in the zigzag position. So we will make these traces in zigzag position. So when we bend this PCB, the traces might not get distorted or eventually broken down. Just double click, left double click on any trace to include a point. This we will copper area and rebuild all to make things more clear. You can see we have zigzag at that position. We will select wire and start our routing. Double click on this, select the in between area and delete that. Similar with this. Okay. Okay, we need to delete this trace because it is already in a slope. Now we will make zigzags. Just make it downwards. We had a clearance issue. The via is so close to the wire. We will just move that via near upward and okay, sorry. We will rebuild the copper area and now we're clear. DRC should be clear. Okay. So we have a zigzag position there and we will do the similar thing at the bottom copper area. First let me rebuild the copper area so it will be more clear. And delete this trace. Here the wiring is completed. Now we will copy the line from the upper layer and place it, copy paste it with the lower layer. We select it and change it to the bottom silk layer and we place it just below the line, just beneath this line. Okay, and now we can see we have our traces are not very aligned, so align them. Rebuild copper area. We will check for DRCs and nets. Okay, we have one unrouted net. We will check for it. We'll look for it in the bottom layer. Okay, here it is unrouted, so just route it in a zigzag manner. Again check nets and it's all clear. Rebuild copper. Save your project and it is nearly complete. Now you in 3D. This line represents the area which can be bent. Now this is the boom file. We have to generate the bill of materials file and we will be removing these headers because we do not need them to be placed. They are just used as a reference, because we will be patching this PCB on a rigid PCB. So just select them all and excavate them from boom. Now again click the boom, and now you can see there are no headers. Export the boom and save it in your desired directory. Similarly, go for GERBER file. GERBER is a PCB manufacturing file. Check the DRCs, and here is your PCB. Generate GERBER. Place it in your desired folder. And similarly, pick and place file. This is also used for the PCB assembly services. Mirror the bottom components and save it. Open your pick and place file. Look for components manually. So here it has also placed the headers. Just remove these headers and cut paste them so they are aligned. Okay, now save your file. There are total 14 components in our PCB. Check the boom, it also has 14 components. Pick and place file and boom file are used for PCB assembly service. While GERBER file is used to make the PCB board. Make a folder and place all the required files in it. Now search for PcbWay. We are done with our PCB. Now we will be ordering it. We go for the PcbWay, and this site, click it, sign in, enter your credentials, sign into the PCB page. And as I have, this is my first order, though they give me a code around $5. Just give it and go to the get assembly code. And we will be going for FPC, rigid or flex PCB, FPC or rigid flex PCB. Just click it and fill these all the fields. Okay, we have flexible PCB, layers are 2 layers, upper and lower layer, single PCB, and length, let's check the length is 35.54 and width is 18 millimeter. Quantity is only 1 for now. Okay, remain this as it is. Remain all these fields as it is. Okay, now go for assembly service. EMI shielding, leave it. Assembly service, choose a turnkey. PcbWay will provide all the components. It's called turnkey, and the assembly side is top side. Quantity is 1. No number of unique parts. Unique parts are like capacitors, resistors, oscillators. So unique parts we have these capacitors, 1 LED, resistors 3, 4, 5 and 6. So 6 unique parts. And number of assembly parts we have calculated earlier, they are 14. Number of QPF for BJP, which is at mega 328, it's 1. Let me show you at mega. Select at mega and check for footprint. It's TQPF here. So we have 1 QPF part. Number of through holes is 0. Click on calculate. So it will calculate your price. It's much because it's a PCB flexible. I have chosen 10 pieces and save to cart. Now they will ask to upload the Gerber file. Upload your Gerber you have saved in your desired folder. Upload the boom file and send try.pick and place file. Now submit your order, and here you go. Here is your order. I hope you like my video. If you have any questions related to PcbWay or JLC PCB or anything related to the EasyEDA routing making PCB, feel free to comment them. I will surely answer your comments as soon as possible. Thank you.